So the topic which we are going to start today are collections class. We'll be looking at few of the things in a collection class which are important for us. Us means for person who are working on Selenium. Okay, so I'll just create a text file. Okay, let me open it with Notepad++. Okay, so the topic which we are going to cover, as I said, we are going to discuss about something known as collections class. Okay, so what all we have in collections class. If we talk about all the topics of collections class, then we have something known as first is lists, second is uh, queues, then we have vectors, and then we have sets. Okay, out of these four, we are going to study one as list and second as sets because queues are outdated now. Nobody is using it. Use queues now, and vectors are something which are not required by us. So we'll skip these two. That is queues and vectors. I'll just remove them. We'll focus on lists and sets. Okay, so in lists we have two things. One is array list and second is linked list. Okay, so you need to learn these two, that is array list and linked list. Then if we talk about sets, then one we have to cover is hash set. Second is second is linked set. Okay, and third one is tree set. So you need to learn these three things in sets. Okay, then there is something else, that is there is something known as maps. Okay, maps are not a part of collection class, but they are generally studied along with along with collection class because they are quite similar. So if I talk about what all we have in maps, so we have three things: hash map, okay, tree map, and linked map and tree map. So what all you need to learn from these three, I mean lists, sets, and maps, how like what is the implementation of these three, and how will you use them in Selenium. That's the only thing you need to learn. Otherwise, lists and sets are very big topic, and I can spend like 4 or 5 days only on collections class. But what we have to learn is that how we are going to use it in Selenium and what all you need for that. Okay, so any questions till now? Okay, so especially these two topics, lists and sets, they are very important. Okay, very important actually. And I'm going to explain you now all of them. So let's start with list. First, this list, it's an interface. Okay, and there are two classes. One is this array list. This is a class which implements list. Similarly, this is also a class which implements list. Then if I talk about sets, sets is also an interface. Okay, and these three, that is hash set, linked set, and tree set, they all the three are classes. Okay, all the three are classes. So just remember, this is an interface and these two are classes. Similarly, this one is an interface and these three are classes. Now let's talk about what is a list. Okay, so list is nothing but a container. It's like a container, okay, which has some memory locations and you can put value in it. You can store values in it. Okay, now the question will come that if it's like a container where you can store values, then what is the difference? Okay, and what is the difference between a list? What is the difference between a list and an array? Okay, so let me talk about few limitations of array and the problem we face with arrays, and then we'll come back to lists. Okay, so first, what is an array? Okay, if you remember, if you recall, when we started array was array was something which had a fixed size and it has some memory location where you were storing certain values. Okay, so let's say I created an array with size 10. Okay, now we started filling values in it, and let's say after some time, all these 10 values got filled. All these 10 values here got filled. Now, what will happen? Can you add any other value? Let's say I have 11th value. Can I you add it? No. So the limitation with an array was that it had a fixed size. If you need more data to be entered, that was not possible. Okay, so we wanted one data structure where we can where we can store n numbers of values. Okay, so then we came up with something known as list. Okay, this list is not a new concept. It was there in C language as well. In data structure part, we used to study this array list as well as this linked list. Okay, but the way we implement array list in C language was that there we used to call it as ADT, that is abstract data type. Okay, and how it used to work was that let's say let's say you need an array list. So what you'll do, you will create a normal array of some size. Okay, and then start filling values in it. As soon as that array fills up, completely fills up, you'll create another array of double the size. Okay, you'll create another array of double the size, and then whatever values you have stored here, you will copy them here. Okay, and then we have extra spaces and you can store values in that, and then we'll destroy this array. This is how it used to work. Okay, so if initially you'll create an array of some size, that size can be anything. Generally it was 10. Okay, and you'll start filling values in it. As soon as you all those values were filled, if you need one more, then another array was created of double the size. Okay, of double the size, and all the values from this array were copy pasted into the new one. Then you have new values to be inserted. You can insert. As soon as that fills up, another array was created, and the older arrays were destroyed after values were copied. So this is how the implementation was. Okay, and in Java, this array list has the same implementation. The only thing is we don't have to do anything. All these things which I just mentioned, that is creating another array of double the size and then copy pasting the values, all these things are taken care by are taken care by Java itself. Okay, we don't have to or for us nothing like that is there. Okay, all these things will be happening at the backend. You will not see. You'll just see that you created an array list with infinite size where you can store as many values as you can. Okay, this array list also has an index. The first value starts with the 0 index, then 1, 2, 3. This array list will also have a data type. Okay, that data type will determine the size of this memory location which you're defining. Okay, so for example, if it's an integer, then it will have a 4 byte size. If it's long, then it will have a 8 byte size. If it's a short, then it will have a 2 byte size. If it's a byte it if it's a byte, then it will have a 1 byte size, and so on. Okay, so depending upon what data type you're using for this array list, this size will be determined. Okay, and it will always be a continuous memory location. Okay, so yeah, so that's how this array list work. Any questions till now?
So what was the disadvantage of arrays?
Yeah, disadvantage was that the size was fixed. Uh, you cannot have anything extra. uh, I mean, if let's say the size is 10 and in at the runtime you need to store 11th element, that was not possible. So if you know that size is fixed or within a range, then you can go ahead and work with an array. If you don't know the size, or size may vary in the future, then you don't have any other option but to use one of the list. So one of the list I mentioned is array list. So array list internally uses array only. It's just that it is giving you a flexibility not to choose the size. Size will be determined at the runtime, that as many values you'll save. Based on that, its size will be determined. Getting the point here, Jishan?
Yes.
Okay. So moving on with the next we have is let's see them how it is actually done in a real time. So I'll just open my Eclipse. Okay, here I'll create a class. Let's say uh, array list example. Okay, so in array list example, I'll create one instance of a class called array list. Okay, so you have to take one from java.utils. Just remember that. Okay, you might find this array list from multiple location, but we have to take one from array java.utils. Okay, so I'll select this. Then here you need to tell the data type in the angular brackets. Okay, whenever you have to define your data type in angular bracket, then just remember that not small int but capital integer is something which we have to put. What is this? What is this integer? If I hover over it, let's see what it is saying. It is saying that the integer class wraps a value of the primitive type int in an object. This integer is a class, whereas that int small int what we used to have, that was a primitive data type, whereas this integer is a class, okay, of int type. An object of type integer contains a single field whose type is int. It consists of only one object whose type is int. In addition, this class provides several methods for converting an int to string and a string to int, as well as other constants and methods useful while dealing with an integer. Okay, so what this is providing us is uh, that it provides us certain methods which are not there in which is not possible in small int, because that's a primitive data type, whereas here we can have multiple some extra methods which will help us uh, in many ways, like converting a string into an integer or an integer into a string, or it provides us certain methods, many methods. Okay, so that's why we are using this here. Now here I'll just give it a name. Let's say array list, any name you can give, equal to new array list. Okay, so now you can see here when I'm defining this array list, nowhere I've given the size. Whereas when I used to create an array, if you recall, if I used to create an array of any data, let's say ARR equal to new int, let's say the size is 10. Okay, so here we were giving the size. So when an array of with the name ARR was created, it used to have a size as 10. But when I created an array list of with the name this array list, here I'm not mentioning any size. Okay, so that means you can store as many values as you can, as you want. Now here I'll say array list. Okay, I need to have a main method. Let me do we have main here? No. Okay, so I will write main. Okay, so here it will be array list. Now when you have to insert value in any in a container, so if I'll just make this container with here, just a second, I'll just create a container here. Okay, so I'll try to explain how addition happens. Okay, so let's say this is a container, and let's say it has index like this 0, 1, 2, 3, 4, 5, and then 6, 7, 8, and so on. Okay, so let's say I have this with me. Now, uh, when I have to insert values, how it will be? Uh, there is a method called add. Okay, there are two methods with this name add. Here you can see add with one argument and an add with two arguments. So the first one is simple add where we are just inserting certain values, whereas the second one, it has an index and a option to insert a value. Okay, so what is this? Let's see this first one. This first one is where it is asking you to insert certain values directly, no index. So whatever value you will put, okay, whatever value you will put, what will happen? It will go and get insert in the first memory location. So what will happen? This 12 will go and will be inserted here. Okay. Now, uh, that will be inserted here. Now let's say you are adding one more value. Okay. Then what will happen? Here also you are not putting any index. So what will happen? This 13, this will go and will not be inserted at this location, but this 12 will be moved to this location. That is, now 12 will be here, and it will have, instead of 12, it will have 13. So what is this? This is always insertion at the, sorry, my bad. I'm really sorry. This is other way around. So let me just explain it again. Um, yeah, so it is like if you have a container and it has a value, so it has certain values. So if you're inserting value one by one, it will always go and get inserted at the end. It's not at the start, but it's always at the end. Okay, so this 12 will get inserted at the 0th location, then this 13th will go and then will be inserted at the next, and just like this, whatever add values you'll have, it will go and get inserted uh, at the last location only. Okay, now any questions till now? So is it clear how it will insert? It will always insert at the last location. So here you can see I have to insert at 12. So the last location which is empty is 0. So it will go and get inserted into 12. This 12 will go insert at the 0. Then 13 will come. So it will go as the filled values are till 0. So the next value which is empty is first index. So 13 will go and get inserted in there. Then we have, let's say I have to insert 15. So the next memory location is at index 2. So values will go and insert in the second location, third, fourth, fifth, and so on. So this is how it will work. Any questions till now? Okay, so next what next will be, there was one more add method I just showed you. What is that? That is insertion at a particular location. Say for example, if I'm saying 0 comma, let's say 15. So if I'm doing this, that I am inserting at a particular index, see, currently 12 is there at 0th index, 13 is there at first index, and if I have to insert something at 0th index, it's not overriding. Just remember this, this is not overriding, but it's insertion. You are inserting here. Okay, so when you are inserting a value, what will happen? As you are using, as we are putting at 0th index, so first we need to make this value as empty. That means we need to make this memory location available for inserting a new value. How to do that? What will happen? Uh, Here, whatever this first index had, this will get inserted or moved to the next index. That means now 13 will come here. Okay. second index will have 13, then this value will get insert here. That means this will have 12, and then this 15 will be inserted from here to here, and this will have 15. Okay, so this will have 15 that. So this is how this works, that insertion at a particular location, if it's let's say 0, so every value will be moved one uh, one value next to the in the next memory location. So 13 will be moved to the next, 12 will be moved to the next, and this memory location will get empty, and here we will insert 15. So this is how insertion in the in the array list works. Okay. Now, do you sense any limitation here or any problem with this structure?
Say, for example, if you want to insert the value at second index,
Mhm.
so then how it will be?
At the current position, yeah, if let's say you want to put any value in the second, then what will
Hmm.
happen? We have to make this value as available, this memory location as available. So how it
Second.
will work? The
Hmm.
second is this, right? Second index is
Hmm.
this. So whatever
Hmm.
value you have here, that will be moved to the
Hmm.
next one. So 13 will
Hmm.
come here. Let's say now you want to
Hmm.
insert 14, then 14 will be written here. So this 13 will be gone. So this is how insertion at second index will happen here. Okay. So it
Hmm.
depends on the memory location, that how many movements you are going to do. If it is like here, it was at second index, that means only one movement was required. Whereas when we had the other example, when we have to insert at 0, there three movements were required. At current situation, if you have to insert anything at 0th position, then see how many movement will be required. This third index will move to fourth, second will move to third, first will move to second, 0 will move to the first one, and then 0 will be available. Okay, so what limitation I'm referring here is that it's a time consuming thing. If let's say, okay, if currently we have only 4 or 5 values, so you might not observe the time, but if let's say we have millions of values in our memory location, then what will happen? Then movement will take a lot of time. Okay, if let's say we have 10,000 records and we are inserting something at 0th position, or maybe in between somewhere, then you need to move all those. If let's say the index is 0, then you need to move all those 10,000 values to one above, and then only you can insert the value. So the main point here is that insertion and deletion from the start is time consuming in array list. But same thing if you're doing at the end, then they are not at all time consuming. Okay. Any questions till now?
Is there any limitation in this list?
Size?
Size, yeah.
No, no limitation. Whatever memory
You
location,
can store.
yeah, you can store any values. Whatever memory location your hard drive supports, you can use consume that much.
Okay.
Okay. So yeah.
But what's the solution for if we insert at the top and there are thousands
Yeah,
of
yeah,
records
yeah, yeah,
available?
yeah, yeah. We'll
So is
come
it
to
a
that.
drawback in this one?
Yeah, it's a drawback here because if you have to do insertion in the start or in between, that's a time-consuming task. So we choose array list when we know or we are sure that insertion in the start or middle is not there. If that's there, then we'll go with another option we have, that is linked list. So there is next topic, that is linked list. So in linked list, this problem will be solved, that insertion in the start or middle will be as quick as it's there in at the end. So that's what we are going to learn now. Okay. Okay, before we move on to that, let's quickly look at whether what other methods we have in array list. So here we can, so what all we method we have? So there is a method called contains. This is to verify. See, the return type of that method is boolean. So what does this method do? This method will just verify whether a particular object is there or not. Say for example, if I say here contains 13. Okay, so I'll just print it whether it contains 13 or not. Okay, so when I execute this code, you will see you'll get a true. Why you're getting a true? Because this array list which we created, it has 13 in it. Okay, if I do something else, let's say I'm saying 16. If I execute the code now, you will see it's returning false because that array list does not contain 16. Okay, like this, what all other methods we have? There is a method called size. What does that do? Size method is to calculate the size of the list. Okay, say for example here I'm saying this. So what will be the size you'll get? Uh, See, at the first we are storing 12, then we are storing 13, then we are storing 15. So that means there are three memory which are being consumed. So the size will come as 3. Okay. So that's the size. It just gives you how many like in an array list how many memory locations are there which are filled. Then we have get method is to get a value at from a particular location from a particular index. Say for example from second index I want to know what is the value. Okay, so if I execute the code, you will see at second index I have a value called the value is 13. So how does that happen? So if I show you, because here if you'll see, okay, what I'll do, I'll just put a debug point here and we'll execute the code in debug mode. So right click, debug as Java application. Okay, so here when I start executing, okay, so nothing is there as of now because we have not created anything. So I'll just step over, that is an array will be created. So here if you'll see, I created an array list. If you just expand this array list, here you can see the size. There is a variable called size. So the size is 0. Then we have mode count, forget it for now. And then we have this element data which does not have any value. Okay, so as soon as I start putting values in it, say for example I added one value, you can see that the size changed to 1, mode count also changed to 1, and if you expand this element you will see that now it has some values. And look at here, it created an array of some size. As I was telling, it will internally create an array of some size. Generally that size for the first time is always 10. That's how the implementation is there. So it will create an array of size 10. If you expand at the 0th location, because we added something at 0th index, you will see a value is added, that is 12. All other values are null. Okay, so when you're calculating the size, it does not consider the null. It only considers the locations which have values. Okay, now if I move on and insert this one also, so if I insert this, you will see that at first index also some value got inserted. But what is the value which got inserted? So it will be 13. Okay, because we inserted 13, and as we have not mentioned any index, so it will always go and insert at the last location. Okay, whatever memory location is available, it will go and insert there. Now next we have is we have to insert something at 0th location specifically. See now, observe how many things will change. Currently we have this 0, so whatever will get changed, that will get updated with yellow. So as soon as I do this, you can see all the three values got changed. That means something has happened. So what has happened is, earlier the at first index the value was 13 and 0 had null value. So here if you'll check, second has 13 now. That means one value was moved to the next. One has 12 now, and this 0th has 15 now. Okay, so value was moved one ahead and then only insertion happened. Okay, so this is how array list works. Now here if I'll just execute this, it is giving me a false because that is not there. And now at 0th, we want to get a value from second index. What does second index has? Second index has a value as 13. So uh, you just need to uh, execute this, and this will give you, okay, white print. Okay, not sure why it printed 3, it should be 13. So it printed 13. Okay, so that's how it works. Any questions now?
3 is the size of the memory.
Oh, yeah. I'm sorry.
Total value.
Yeah. So sorry. So 13 was printed because of the size, and then, uh, yeah, I just thought, I mean, something incorrect happened that time. Okay, so if I execute it now, you will see 3 is for size and 13 is the index value at index 2. Clear? Any doubt? Any questions here? Okay, so moving on to the next one. What all methods we have? So we have other methods like isEmpty. So isEmpty is again a Boolean method which will return you true if the array list you are trying to access is empty. Remove means you want to delete any value, so just put remove and give an index. So how does this works? Let me show you again it in debug mode. So if I execute it in debug mode, okay, so I'll execute this, an array list is created. Again you'll see the size here is 0, but it currently does not have any. As soon as you insert a value, it will have an array of size 10. Okay, now how will it work? Okay, so I'll just insert these values. Okay, now I'm at this position. So currently you can see values are there at 0th index, it's there at first index, and then it is there at second index. So as soon as I execute this statement, you'll see that two values got changed. Okay, why? How? The second became null, and then first index has the value which was there at second index. Okay, so first index has the value which was there at second index. Why? Because in the deletion, how it happens is, if from a memory location a value is being deleted, that will you'll just delete that value, and then whatever value you have in the next one, you will insert in one before. Okay, so not only insertion but deletion also takes time. How? Let me quickly show you with an example. So let's say this is an array list and you have certain values. Okay, it has some value, let's say 3, 4, 5, 6, and so on. Okay, 7. Okay, so let's say I want to delete value from here. So what I'll do, I'll just move this 5 to 4, then 6 to 5, and then 7 to 6, and we'll make it null. So this is how insertion happens. So again you can see I wanted to delete one value, but how many operation happened? 1, 2, 3. So 3 operation happened because of the size of this array. If the size is more, let's say 10,000 values are there and you are inserting or you are deleting something from start or in between, then there it will consume a lot of time to remove the values. Okay, so insertion and deletion both take time in uh, in array lists. Clear? Any questions? Okay, so I'll come back a minute.
So where can we use this array list then?
Yeah, I'll come to that also. Let me just
Okay.
complete all these things, and then I'll
Okay.
I'll mention when to use array list and when to use linked list. So let me just complete
Sure.
them. Okay.
Okay.
So next comes is array list dot is empty. Is empty is just to verify whether an array list is empty or not. Okay. This method is to array. To array is to convert an array list into an array. So what happens in that case is, if you're converting an array list to an array, whatever data size you have that time, the same data size will be there for that array, and then you will not be able to insert any new values. Let's say at the time you called this method, an array list had 5 values. So it will convert it into a normal array with 5 size, and then you cannot insert any new value. That's what this to array means. Add we have seen, add with this other one we have seen, contains we saw, get we know, remove we know, size we know, and others you can just go through, not used much. So wherever this array list is written, uh, just select that and just read about what that method do, or you can check the Java docs. Uh, Generally speaking, whatever methods I have mentioned, I have not used any other method other than that. So they are more than enough for us. Okay, so yeah, so this is done. Array list is done. Any questions?
Can we calculate the empty spaces in the list?
For a list, empty spaces are something which is internal. For you, empty spaces should not matter. Why I'm saying this, because when you're creating an array list, you don't know the index. So for you, index is, or the size is, whatever values are inserted. Remaining how Java implements, that's something which we don't care actually.
Okay, got it.
Okay. One
So
more.
clear method will clear all the list. I mean the entire list.
Yeah, clear will just make everything empty.
Okay, and what about clone? Clone means it will create a duplicate array list.
Not sure what does
Or
this
what?
clone do.
Oh,
Never used.
okay.
So
Okay, that's fine.
there are many methods which I have not even seen. But yeah,
Okay.
you can just go through their Java docs and see
Mm-hmm.
what is it.
Mm-hmm.
Okay. So I'll just remove this. Okay. One more thing you need to learn in array list is how to iterate over a list, because this array list is will be going to be a very big. Here currently we just have 5 6 values, but in real time you might have somewhere around 1,000 values in an array. So it's important to know how to iterate over an array. So to iterate over an array, we have a for loop. So we'll say for, and then uh, I'll be using the enhanced for loop. So if you recall how enhanced for loop used to work. Okay, so here in that, first of all, you will tell the data type. So here the data type will be integer and will be using the class name instead of int, because when we are defining array list, it is the class name. Okay, then give any temporary variable. Let's say I'm just calling it as temp, then a colon, and then name of array list over which you are going to iterate. So I'm going to iterate over array list. Okay, now here this is it. Now system.out.println, for now I'm just printing it. Okay, now how it will work, you'll just I'm iterating over this array list. So values from this array list will start coming one by one. So again it will come from the 0th index, and then first index, then second index, the third index, and so on. Okay, so if you want, I can show you it in debug mode. I'll just close this. So here you can see I have an array list. If you check its size is 5. So how will it work? Let's see. So currently there is no temp variable, if you'll see. So when I execute this statement, a temp variable will be created. What does this temp variable have? This temp variable has something, uh, a value which is there at the first index of this. So if you see at the 0th index we have a value 15, and that same value 15 came here. We'll just print it here, or whatever you want to do you can do. Then temp variable is gone. As soon as you execute this statement again, that temp will be created again, and this time it will have a value 12, and 12 is a value which is there at first index. So like this, values one by one will be inserted in the temp, and then you can use that. So this is how an iteration over an array list works. Any questions?
Can you explain me that for loop one more time, please?
Okay, sure.
That enhanced for loop.
So this enhanced for loop, how it works is, okay, you have missed arrays classes, right? Okay, so how does an enhanced for loop work? Uh, it has this keyword as 4 only, and then in the round brackets, first you tell what is the data type. So here you can see the data type of this array list was integer. So here also I've given the data type as integer. Then here you mention some temporary variable. So I just give a variable known as temp colon array list. Uh, colon array list means on which you want to iterate. So here you can give an array list, a linked list, a set, a map. You can give anything, okay, over which you want to iterate. So here it can be a collection or an array. Is this clear? So this is the syntax. First you give the data type, then a temporary variable, colon, the name of the array over which you are going to iterate, or the name of the array list over which you're going to iterate. Then
Yeah.
how it works is, in this temp variable, values from this array list will come one by one. As I was showing, for the first time temp had the value which was there at the 0th index. Then it had the value which was there at first index. Then if I execute it again, if I execute it again here, you will see it has value uh, from the third index. So here value is 13. If you'll go and see the second index, it has a value 13. So value will be coming from indexes one by one. Okay, clear, Sandhya?
Yeah, yeah. Thank you.
Okay, so moving on to the next. Yeah, that's all. Okay, one more thing. We can iterate using the normal for loop as well. It's not compulsory that you have to use an enhanced for loop. You can use normal for loop as well. How will it work? For int I equal to 0, index will start from 0 itself. Then I less than the size of the array list. So it will be array list dot. We know to get the size we have a method called size, and then I plus plus. So it's as simple as, or as similar as, we are iterating over an array. Okay, so the only difference is here we are using a method called size, whereas in the array we used to use a property called length. Okay, and here you can simply say uh, array list dot, then to get the value we have a method called get, and here just give the index. So this will execute the code. Yeah, so any questions in the normal for loop? Okay, so this,
I think in arrays like we don't have get
yeah,
method, right?
in array we don't
Array,
use.
array.
Then in the square
Yeah,
bracket you give the index,
yeah,
whereas in
yeah.
array list
That's right.
you have to use this method called get.
Okay, okay.
Okay, so that's the only difference. And it was actually asked to me in one of the interview. Here in India there is a company called BlackRock. Okay, in that I was asked this question, that what do you use in array to get the size and what do you use in a list. So in array we use dot length, that is a property, whereas in array list or linked list or set, we use a method called size. Similarly, to get the value in arrays we use square bracket, whereas in array list we use dot get method. Okay, so any questions? Okay, so moving on to the next we have is okay, so next we have is linked list. So let me first explain you what is a linked list, and then we'll probably move on to its implementation. So how does a linked list work? So we saw this array list and we got to know that there is an limitation in it. Limitation is that if you have good insertions in the start or in between, then it will take a lot of time, which is not good. Okay, so then came up this linked list. Linked list has its own advantages and its own disadvantages. Once I'll explain you linked list, then we'll discuss which to use and when. Okay, so how does this linked list work? Linked list, in linked list, we have something known as nodes. Okay, so there will be multiple nodes. Okay, so for example, I'm just creating 3 nodes and one more here. Okay, so in linked list, we have multiple nodes and those nodes are not in continuous memory location, but they can be there anywhere. Okay, and that each node has two things, or you can say two part. One is the size of the memory where you want to store the data, and second is the size where one can store the address. Okay, so let's say this is my 0th index. Okay, let's say this is my 0th index, and 0th index I want to insert some value, let's say 13. So I inserted 13. Now, what does this it means? This is something known as top. Top means the start. Okay, what does this top has? This top has the address of starting memory location. Let's say the uh, first this starts with 2000. So this will have 2000. What does that means? That means the starting of this array list is from 2000. Okay. Now, what does this second memory part is? So first is where you are storing a value. Second is where you will store the address of next memory location. Say for example, next memory location is at 4000. Okay, so this the address will of this starts with 4000. So this will have the address of next memory location. Similarly, this will have address of next memory location and so on. Okay, so every node has two parts, one where we are storing the value and second where we are storing the address of next memory location. Okay, like this. Maybe here we have is 5000. Okay, so let's say this is 5000. Now what will happen if you have to insert anything or delete anything from any memory location? Say for example, I want to insert a value called maybe 12 in between or at the 0th index. Okay, so what you'll do, I want to insert 12. So what internally it will do, it will create another node of the size of the data type and will have two parts, one where we can store that 12 value, so you'll just go and store the 12 value, and second memory location will store the address of next. Okay, so as I have to insert this value at the start, so whatever earlier we have at the start, that value will the address of that value will got store here. So in the memory location we'll store 2000. Now this 2000 is pointing to this. Okay, so this is pointing to this, where also this is pointing to this. What I have to do to make it 0? To make it 0, I just have to move this to this. Let's say this value is at 1000 memory location, or starts with 1000 memory location. So the only thing will change here is this, and this will be gone. Now you can see this top is pointing to 1000 one, which has 12 and 2000. 2000 is the address of next memory location, then 4000 is the address of next memory location, and so on. So you can see insertion, how quickly insertion happened. Just two insertion: one, the memory address of 0th index, earlier 0 index, and updating the top with address of this new. Okay, whereas in array list, what was happening, you were moving all the values one down, and then insertion was happening. So you can just imagine how quick it is, right? Any questions till now? Is it clear how insertion happens in case of linked list? Okay, so as there is no question, let's move. So now what is the limitation here? I mean, this is good actually, that we can insert at the start just like that. Now what is the limitation? So the limitation here is, look, just to store one value, just to store a value called 12, I had to store, or I have to consume two memory location. One where address is getting stored, and second where actually memory actual value is getting stored. So memory consumption is very high in case of linked list, but it solves the problem that if you have good insertion in the start or in between, then time consumption will be less. So if you have to choose one out of two, what you'll do, just look at your problem statement and see what requirement you have. If you know that your insertions and deletions are going to be there in the start a lot, don't go with array list, go with linked list. In case uh, your memory is or your data size is less, then go ahead with array list, because in that case this time problem will also be resolved, and you will be storing less value. But if the size of uh, of the array list of the list is too much, maybe millions of records are there, then I'll recommend you to go with linked list. The reason is, let's say you have 1 million values and all those 1 million values got stored. Now you have to add one more. Then internally it will create another array, and then you need to insert that new value, copy paste all those value, and then insert a new value, which will be too much time consuming, and the new array which will be created, that will be of bigger the size. So you may not get continuous memory location of that much size. Okay, but in this case, as in the linked list, the nodes are created randomly at any location. So even if you want to add another value, just one node is required, not a bigger array, and there is no copy paste. Okay, so just remember these points. First point, use array list when data size is less. Second point, use array list when insertion and deletion in the start are less, insertion at the end is more, or reading the list is more instead of insertion or deletion, then go ahead with array list. Whereas when to use linked list can be used when data size is very high, very large. Second, when when insertion and deletion in the start are more, or even if at the end is there, then also it's not too much time consuming. Okay, so insertion and deletion operations are more, then go ahead with linked list. Whereas if get operations are more, then go ahead with array list. Okay, so these are certain points to decide. Any questions now? Okay, so now next thing I'll show you is implementation of the same in case of linked list, the way we learned in array list. But before that, let's have a break for 5 minutes and then we'll continue. Questions before we go to break? Okay, so see you after 5 minutes and then we'll continue with other topics. Okay, so let's continue now. Okay, so what I had to explain is I'll just copy this array list example and paste it again, and we'll change the name to from array list to linked list. Okay, and here I'll change this array list to linked list. Okay, and rest everything remains same. So the methods which are there in array list, exactly same methods are there in linked list. Just need to rename the name, right click, refactor, rename it as linked list. Okay, so everywhere this array list was changed to linked list. Rest everything will remain same. Same method to insert at the end, same method to insert anywhere in between, same method to contain to check whether a particular element is there or not, same method to get the size, to get the value, same way you will iterate, same way you will iterate using enhanced for loop. Okay, nothing changed. So the only thing is you need to just know what is the way it implements. Rest everything uh, will remain in both. So you don't have to remember that what is the method in array list or what is the method in linked list. Okay, and how does this happen? How both of them have exactly same method? This is because of this interface. All those methods which you're seeing here, uh, like this add or this get, this contains, whatever method you're seeing here, that are actually there in list, array list and linked list are implementing them the way uh, I mean differently. Array list has its own way of implementation, whereas linked list has its own way of implementation. So in a way, you can say that this instead of this list, I mean here you're when creating an instance, instead of using linked list, you can also use only list from java.utils. That will also work fine, and you can see there is no error. So I've created an instance of list interface, but initialize it with linked list. Any questions here? Okay, Sandhya, are you saying something? I cannot hear, but see you are unmuted. So, are you saying something? Sandhya, you there? I mean, are you asking? Okay, fine. Okay, so this is how linked lists and array lists are there. So you just have to remember these points, then when to use which. And the good point is, or a good thing is, when you're actually using these lists, you don't have to worry about anything, whether it's an array list or a linked list, because uh, uh, why I'm saying this, because whatever values you will get in Selenium, that will always be in lists. Okay, so for us it won't matter. Directly implementation of lists will be there. Okay, so yeah, Sandhya, you have a question. List can be used instead of linked list. Here you saying, I mean, yes, I just created, I mean, just this instance, sorry, this list is an interface, right? So interface, you can create an instance of an interface, but you cannot initialize with an interface. So for to initialization, you have to use one of its implemented class. So either you can use array list or you can use linked list. So I just gave one example with linked list. You can use array list also. So if you'll initialize it with linked list, it will have an implementation of linked list. If you'll initialize it with array list, it will have an implementation of array list. That's the difference. Okay, and then we have contains method, we have size, rest everything will remain same because the all are coming from this list. Okay, so that's all in lists. Okay, now there will be many examples where this list will be used in Selenium that will take care as soon as we'll start Selenium again. Now I'll quickly give you, let's quickly discuss about the sets. Maps maybe we'll discuss, maps where we will discuss tomorrow. Okay, so let's start with the sets. Sorry, right click new class sets example. Okay, so in sets, as I just mentioned, there are three sets: hash set, linked set, and tree set. What does this set have? So I'll just try to create and then I'll explain. So what is this hash set has? Hash set, again you have to take one from java.util, and here also you'll tell the data type. Let's say I'm taking data type as an integer. Okay, any name you can give. Let's say I'm giving a name as hash set itself equal to new hash set. If you look here, again I'm not giving any size, so it's quite similar to list in this way that no size is there. Now if you recall sets of mathematics, what we used to have, set was like was something where you had multiple values, right? And they can be random values. So here also we when we are inserting any value, okay, let me use the main method. Okay, so when I say hash set dot, I say add. Here you can see there are not. I mean, in list there were two add methods, one without any index and second with index. Whereas in hash set or in any set, you don't have the other method. You only have the one. Why? Because sets does not have any index. They does not have any index at all. You can only insert values. Say for example, here I inserted 12. And the second thing is they don't allow duplicate values. Okay, so if I insert some values, okay, so here when I inserted these values, okay, so just to print, I'll just put this hash map directly, hash set directly here, and when I execute it, you will see it's like a set where you have multiple values. Okay, 17, 89, 10, 11, 12, 15, and look at the order. Order is just random order. No indexing is there in this. Okay, so when you insert the value in a hash set and when you receive or iterate values, so it might happen the order in which you are adding the value uh, and the order in which you are getting the value can be different. So here you can see the order in which I'm inserting the value is different from what I'm receiving. I'm inserting 12, 15, 10, 17, 10, 11, 89, and you're receiving something else. And duplicate values are not allowed. You have 10 only once, not twice. Okay, so this is about hash set. Hash set is, or any set is something where duplicate values are not there and they don't allow uh, and they don't have index. In case of hash set, the order in which you insert the value and the order in which you receive you iterate the values uh, can be different. Okay, or you can say will be different. I mean, you'll always get the different order. Okay, any questions till now? So what do you think? When will this hash set is important? Okay, hash set is important, or any set is important when you need to insert unique values all the time. Okay, you don't want, or you don't have any duplicate value. In that case, you'll be using sets. And when the order is not important, then you can go ahead and simply use hash set. Okay, so I'll just copy this part, and maybe I'll copy it again. I mean paste it again, or let me create another class and then I'll copy. So I'll just rename it to maybe hash set examples. Okay, I'll just copy this class and paste it again, and this time I'm saying linked set example. Okay, in linked set, I'll just quickly change this to linked set. Okay, actually it's linked hash set. Okay, linked hash set. Let's say I named it linked. Okay, I need to rename it. So copy, right click, refactor, rename. Uh, it is linked hash set. And this I'll copy here. So what is the difference? Difference you'll find when I'll uh, execute it. See, the order in which you inserted the values, same order you're getting in return. No duplicate values. So what does this linked hash set do? It maintains the order as well. How will it maintains? Internally it is working just like your linked list, that first memory location has the address of next, and then next, and then next, and so on. Okay, so this is how linked set work. Just remember this and then quickly see if, okay, control Z, what I did, right click, delete. Okay, I'll just copy this hash set, paste it again. Okay, so this time we'll talk about tree set. So in case of tree set, uh, so in case of tree set, what is okay, let me just execute and probably you can identify what is the order. So Sandhya, you were asking about unique values. Yes, unique values, it will always have. All the sets will have unique values. That's for sure. Okay, and look at here. In case of tree set, the order is alphabetic order, or you can say increasing order, ascending order. So if it is integer, you will get ascending order of integer. If it's a string type, then you will get alphabetic order. I mean A, B, C, D, and so on. Okay, so yeah, that's how it works.
In which scenario we use tree set, hash set, and all those?
So the same thing I told, that hash set is I mean, when you have to store anything unique, then you are going to use sets. And how to choose the one? If you don't worry about the order, then go ahead with hash set. If you know, if you want the same order in which you are inserting, same order should be returned, then go ahead and use link hash set. And if you want alphabetic order, maybe increasing or decreasing, ascending order, maybe increasing or decreasing, then go ahead and use tree set. In Selenium, generally speaking, will not use any of the three. We'll be using directly the sets. So as I told you, sets is an interface, and these are three three of them. So you'll not be using until unless you are writing certain logic where you want to use ascending order value or link or the order in which you're inserting same order you want as back. Then in that case you might use these three, otherwise directly sets will be used. Okay, so Sunday you have this question, what is the order in linked set? So in linked set the order is the order in which you'll insert, same order. Okay, if I execute it, the order in which you are inserting, same order you'll get as an output. Okay, so yeah, that's all in sets for now. I mean, for us, maybe if you like these topics, you can go ahead and learn about them further, because it's a very vast topic. You can learn many things. This is important if you're going for few companies. One of them I know is Amazon. Amazon is something which talks about data structures a lot. So they might ask you questions in data structures a lot. Other than that, generally companies don't ask much questions from data structures. And this Amazon is there. I mean, it's a common pattern in all the countries, be it US or India. I mean, I'm aware of these two countries. So in both, they they ask questions from data structures. Okay, so if you recall, in our college, we used to have a complete subject as data structures. I mean, I had that data structure as one of my subjects. So yeah, you can learn a lot in this. Okay, so then we are left with only maps. Maps are, uh, I mean, they're quite similar to this. So we'll talk about them tomorrow, because it's already the time I have to start my next batch. So tomorrow we'll start sharp 8. Today I just had to go somewhere, so I asked for half an hour delay. Tomorrow we'll again start at 8, and then we'll continue with this topic, and